Hello. In this video, I'm going to show you how you can make use of Excel to conduct a hypothesis testing. I will not put too much time on explaining the theory of hypothesis testing as you have learned them in quantitative techniques or other foundation program, right? If you cannot recall the basic concepts of hypothesis testing, I strongly advise you to do a revision. However, I will briefly touch on the basic concepts on hypothesis testing to refresh your memory. My objective for this session is use Excel for financial modeling and to apply them in hypothesis testing. Let's start. Hypothesis testing is a formal procedure for investigating our ideas about the world using statistics. We can use the information in the sample to make inferences about the population. Hypothesis testing typically begins with some theory, claim, or assertion about a particular parameter of a population. The null hypothesis represents the status quo or the current belief in a situation. The null hypothesis is identified with the symbol H0. The alternative hypothesis, H1, is the opposite of the null hypothesis and represents a research claim or specific inference you would like to prove. The equation of a linear equation is y equals to a plus bx. To determine the existence of a significant linear relationship between the x and y variables, we conduct a t-test to test whether beta is equals to 0. The null hypothesis statement is beta is equals to 0. For alternative hypothesis statement, beta is not equals to 0. When beta is not equals to 0, there is a linear relationship between x and y. A test statistic is a number calculated from a statistical test of hypothesis. It shows how closely your observed data match the distribution expected under the null hypothesis. For a t-test on beta coefficient, here is the formula to calculate the t-test statistic. The critical value divides the non-rejection region from the rejection region. You can make use of the Excel formula shown in the slide to derive the t-critical value for a two-tailed test. Let's have an example. We are going to perform a regression analysis on the return of BP and the return of FTSE 100. Our sample data consists of the daily return of BP and FTSE 100. In total, there are 641 observations. I'm going to calculate the beta of BP, so I will regress BP's return on FTSE 100's return. The return of FTSE 100 is the independent or explanatory variable. We call it variable X. The return of BP is the dependent variable. We call it variable Y. First, I shall generate the regression output. I'm going to click Data, Data Analysis. I will select Regression, click OK. Then the input Y will be the stock BP. I'm going to point BP, press Ctrl Shift down, highlight the data range of BP. For input X range, I'm going to point FTSE 100, press Ctrl Shift down, and highlight the data range of FTSE 100. Do I have a label? Yes. So I ensure that the label is ticked here. Output is where I want to put my results. I want to put my result here, so I click here. Then I click OK. This is the result from regression. From the regression output, we can calculate the test statistic, which is shown here. The test statistic is obtained by taking the beta coefficient negative 0.1146 minus the hypothesized beta 0.5, then divide by the standard error, which is 0.06602. So we obtain a test statistic of negative 9.309. The test statistic is lower than the t-critical value. The t-critical value for a two-tilt test is either positive or negative of 1.964. In this case, we shall reject the null hypothesis. From the regression output, the beta of BP is shown here. I shall highlight this in yellow for you to see clearly. The beta of BP is negative 0.11465. The p-value is shown here. Let me highlight this in blue. The p-value is 0.08. This means beta is significantly different from 0 at the 10% level based on a two-tilt test. You can also observe the p-value to decide on the region of rejection. The key is, if the p-value is low, then null hypothesis must go. If the p-value is greater than or equal to alpha, do not reject the null hypothesis. If the p-value is less than alpha, reject the null hypothesis. I hope you truly enjoyed this session. Thank you.